Okay guys, in today's workbench video, we are going to talk about an equipment whose primary job is to generate time varying signals. And the name of this device is the signal generator or function generator. And I'm being a bit careful here because legendary books such as The Art of Electronics distinguishes between a function generator and a signal generator. So for readers who are conversant with that book, you might find out that I'm mixing the terms here, but the reality also is that most of these functionalities have been combined into just a single device. So as you can see here, this is my signal generator or function generator. And the particular model that I have is Siglent SDG830, as you can see up here. If you have watched the previous workbench video, you remember that we spoke about the oscilloscope. And for me, in a very loose description, I'd like to say that the function generator is the opposite of the oscilloscope. And the reason I'm saying this is that the oscilloscope basically plots out voltage over time, right? So it's helping you look at how voltage, and for that matter, signal also, is varying with respect to time. The function generator is that device which has the capability to produce time varying signals. So for me, I see them as the opposite of each other. Well, if you have been in electronics for a while, you remember that, or you would have noticed by now that things get interesting in electronics when voltage or current is changing or varying with respect to time. This is when we begin to do awesome things with electronics. And so it becomes necessary for you to have such an equipment, especially when you move out of the time domain analysis of circuits to the frequency domain analysis. So in time domain, you are more interested in how voltage or current is changing with respect to time, right? But in frequency domain analysis, you are interested in knowing how the amplitude of your signal is varying with respect to something like frequency. And a typical use case is when you are talking of filters, right? So let's focus our attention on this device and then let's learn a bit about the scary looking buttons there, even though it's a very simple device to use. So again, this is a Siglent function generator, but everything I'm teaching you applies to any other function generator out there. Most of the time, you will find dedicated buttons for generating specific kinds of signals. And by the way, we will do some radio transmission experiment with this signal generator in this video, so stay tuned. So on mine, you can see that I can generate sine wave, I can generate square wave, I can generate a ramp, I can generate pulse, I can generate noise and arbitrary signal. So for the arbitrary signal, you have the capability to control almost every aspect of the signal. And as a matter of fact, I could have done this video with a scope here. I actually have my scope right up here. I could plot it, but I want us to focus entirely on the signal generator. All right, so what do? You first of all start by pressing that particular kind of signal that you want to generate. And of course, it depends on the kind of circuits you are building or analyzing, right? So now you can see the sine wave button is the one that is lit, and that means this device is in the mode where it is going to generate sine waves. And so the parameters that you can control are going to correspond with the parameters that are controllable based on the signal type that you have chosen. At the moment, you can see that my amplitude is set to 8-volt peak to peak. That's why you see the PP here. And I don't have any DC offset in it. So this is a sine wave that is centered around 0 on the vertical axis. And you can see that my frequency is 2 hertz, 2.0000 hertz. So what it means is that it is changing cycles 2 times in a second, and you can also control something like the phase angle if you want to. Once you are done changing or manipulating the parameters that you want, and by the way, you can change the parameters by also pressing these menu buttons. So these are also context aware. What they do depends on the signal type that you have selected. All right. So at the moment, let's say I want to change my amplitude. What I have to do is I need to look at the button that corresponds. Sometimes one button controls 2 parameters. So I can press this one here. You see, it's cycling between frequency, period, and then this one cycles between amplitude and then high level. So you just have to figure out which one you are controlling by looking at what is highlighted. And then it has this knob that is used for controlling almost everything. So if I change this, you can see that as I go up, my amplitude is changing. It was 8-volt peak to peak. Now it is 10-volt peak to peak. I'm going to put it back to 8-volt peak to peak. And this is how the connectors look like. So there's a red one and a black one for ground, right? And you have to hook it up to whatever system or circuit is under analysis or steady. Okay, just to demonstrate, I have this very simple LED circuit made here, very simple to follow. So my positive rail is up here, it's going through a resistor, and then I have the LED connected to ground through here. So I'm going to hook this up to the signal source, and then we see what the signal is doing to the circuit. So I'm hooking the red to the positive rail, and I'm hooking the ground to the negative rail. And then I'm going to hold it in a way that you see properly. At the moment, nothing is happening regardless of the parameters that we have set. And the reason is that for my specific function generator, you have to press this button here for it to begin to output. So now you can see that the LED is blinking. And like I said, in electronics, we begin to do interesting things when we have voltage or current varying with respect to time. And if I didn't have this signal generator, I would have to probably use some transistors or some 555 timer IC configured as a multi-vibrator for it to be able to blink this LED. So I mean, just by having the function generator, it saves me from having to build some of these circuits just to try out or analyze how certain systems respond to such signals, right? So I'm going to change the frequency. I think yeah, we can still see it blinking here. So I'm going to change the frequency. So you have to use the context aware menu button. So now it's on frequency, and then I'm going to change it all the way to, let's say, 10 hertz. And if I turn it now, you can see that the LED is blinking way faster. And what is actually happening is that it's blinking 10 times per second, right? So I mean, all you need to know about signal generators or function generators is that they help you to generate time varying signals. Nothing so fancy to learn about them. And like I said, you just choose the particular signal. So if I change to, let's say, square wave, for example, it's not really changing the behavior, because if you actually wanted to blink an LED with, let's say, a microcontroller, you are going to use a square wave in the form of pulse width modulation, and this signal generator is able to do that. So when I change to square wave, you see that the kind of parameters that I can control have sort of changed a bit. Like right now, you can see the frequency is 10 hertz, it's 8 volt peak to peak. And then I can also change the duty cycle, which is written down here, right? So the duty cycle basically determines the on time of the square wave. So a square wave is alternating between on and off, and how long it stays on is what is known as the duty cycle. So if I increase the duty cycle, then basically the average output of the square signal is also going to increase, right? So let's say I come to my duty cycle here and then I reduce it like this. For the LED, because the frequency hasn't changed, a change in the duty cycle is actually going to show as a change in brightness because of the average power that is being outputted. Okay, so I mean, again, nothing too fancy about that. You can also see you can generate a ramp. A ramp is basically a circuit that start from some point, a voltage or a signal that starts from some point and rises over time to another particular value. And there's a pulse. So the difference between a pulse and the square wave is you can just set the pulse to happen over a particular time. For the square wave, it's also going to be repeating, and you can control things like the weight, the rise time, and of course always the amplitude and also the DC offset if you don't want it to be centered around 0. If you're working on any circuits where you also want to see how your circuit responds to noise, you can use this device to generate noise and use it to analyze your circuit and to see how it responds to noise. All right, like I promised in the beginning, I said I am going to let us conduct some radio transmission experiments with this device. So let's get started. I'm going to go back to let's say my square wave. It doesn't really matter. I can also use the sine wave, but I'm going to use a square wave for now. And I'm going to disconnect from the LED circuit, so it's out of the way now. Now, you know that to transmit radio, you need at least 2 signals. The first one is the carrier signal, and the second one is the actual audio data. So let's think in terms of AM here. My function generator can also do AM modulation, and also that is amplitude modulation and also frequency modulation. So to prove what I'm going to show you, I have a radio in my hand here. I don't really need to pull my antenna because it doesn't matter in this case. It's very close to the signal source, but I'm going to put it here and then I'm going to turn it on. Okay, so I'm going to put it in AM mode. Sorry, let me reduce the volume. Yes. Let me reduce the volume so it doesn't get in the way of this video. I'll turn it up when necessary. Okay. So you can see that this radio is tuned to 1500 kilohertz. And in my area, there is no transmission happening on 1500 kilohertz. I'm going to talk louder here because of the hissing or humming sound from the radio. So you can see that in my area, there is no transmission happening on the frequency 1500 kilohertz. So what are we going to do? What we are going to do now is I'm going to set the frequency on my function generator. Okay, so this is at frequency. Let me put a frequency, and then I'm going to put in 1500 kilohertz. Okay, so now I have my carrier signal, which is transmitting at 1500 kilohertz. You might ask yourself, okay, but nothing interesting is happening here. Of course, you can see 1500. I'm just trying to, yeah, you can see 1500 on the radio, and that is also the frequency that I have set here. Now, the interesting thing happens when I turn on the output of the signal generator. And then I'm going to connect a 100 ohm resistor, I'm going to connect a 100 ohm resistor across the output of the function generator like this. So right here, I just have a 100 ohm resistor connected across the output of the signal generator. And that becomes my sort of an antenna, okay? Now, look at what happens the moment I turn on the output of the signal generator. Can you hear that the humming noise from the radio has ceased without me doing anything? So look at it. If I turn it all the way up, the volume is up. If I turn off the output, look at it. So you see that indeed some transmission is happening on the frequency 1500 kilohertz when I turn up, or when I turn on the output of the signal generator. Look at it again. I'm going to turn it on, and the radio has begun receiving, because all you need to transmit radio is to have a time varying signal moving up and down a conductor. And this right here, the resistor across the output, is basically serving as an antenna that is producing at 1500. To prove that, if I change to let's say 540 kilohertz, 540 here. Let's wait and see. So you can see that this is not responding to the output, but if I go to 1500 as I have set, okay, so now you can see that it is actually receiving something from the simple setup that I have there. Now let's go back to the signal generator, and then I'll show you how to modulate sound over it so that we can actually begin to hear some sound on the radio set here. I said my signal generator supports AM or FM modulation. So in fact, let me turn this thing off first. Like, I'm turning it all the way down. So if you come here, you have to choose the type of modulation that you want to do. There is FM and there is also AM modulation, right? Now the first thing you want to do is you want to choose your AM frequency. So this one, I'm going to choose some frequency that the human ear can hear. So let's start from, let's say, 240 hertz. And already you can hear. Let me turn it up. I'm trying to find a good place to position this radio so that, okay, maybe here is okay. Sorry for that disturbance. Let me position it well. I just want you to see. Okay, maybe here. That also gets out of the way. Okay, anyway, I'll just put it in my hand. So you can see that it is indeed receiving on that frequency 1500, and I'm playing a tone, like I'm modulating the tone at 240 hertz. So if I change the frequency of the tone that is being modulated, the tone that you hear on the radio set should also change, right? So look at it. You see? So I mean, I know the human ear can begin to hear from 20 hertz all the way to 22,000 kilohertz, but it also depends on your age. This is 30 hertz. I'm not hearing anything. Let's go up. I think I'm beginning to hear something. It might be hard for the camera to pick up, but I can hear. Yes, at 80 I can hear, 90, 100. Now it's getting louder, 140. So guys, this is it, like I said at the start. And to prove that I'm actually transmitting something, if I turn this off, the radio just gives you noise. So that is it. like I said at the beginning of the video, there isn't much to learn about the function or signal generator except the fact that it helps you to generate signals or voltages that varies with respect to time. And we have also conducted a very simple radio transmission experiment. I hope this inspires some creativity in you. It inspires you to also conduct further experiment to see how far you can take this. Thank you very much for watching, and I will see you in the next video.